Hello everyone, welcome to GChem classes. So today we are going to discuss spectroscopy's first topic. Okay, in spectroscopy we have Beer-Lambert's law. In that Beer-Lambert's law we are covering ultraviolet UV, and then we have rotational, then we have vibrational, then we have NMR. So we'll discuss it. We'll just divide it and we'll discuss it based on the problem they have asked, like PYQs. They have asked the problems. Based on that, we are just dividing. So today I'm going to deal with Beer-Lambert's law and some of the ultraviolet radiations, like whatever questions they have asked in these two topics, I'm going to discuss it, correct? So be with me and learn this Beer-Lambert's law, okay, in different way, correct? So today we are going to learn this Beer's law and Lambert's law. So first we'll see Lambert's law. What it says. First just we'll do one graphical representation. Let's see. It's our incident radiation. This will be transmittance, and here it is like we have this path length. Suppose this path length is x. From here to here distance is x. Okay, and then we are taking the concentration C. Okay, the solution concentration C. So generally for Lambert's law and Beer's law, just leave it. Simply you just see, we have kept a sample here, right? This is a cuvette. Okay, this is a cuvette. In this cuvette, we just kept our sample. Okay, and we know that this path length is x. Okay, generally it will be 1 centimeter. Okay, path length means this breadth of this cuvette. Okay, and then you have to fill the sample. Okay, there will be a mark in cuvette, so you have to fill the sample till that much mark. Up to the mark you have to fill it up, and then this concentration of solution, it will be known concentration, right? You will be knowing the concentration because you are just finding out the absorbance. Okay, how much absorbance this particular solution is giving and the particular compound, correct? Now what happens? This radiation is passing. This is incident radiation. Okay, I0 is incident radiation. It means and this radiation property is, this one is monochromatic, correct? This one is monochromatic radiation. Monochromatic radiation means we have different wavelengths, correct? The sunlight, it is coming. In that sunlight, what is happening? We have different type of wavelength in that. So what we have to do, we have to just filter it out, all those wavelengths, and our requirement, what we want, that wavelength radiation, we will take it up with monochromatic radiation, and then we are just passing through this sample. After the sample, because when this radiation will reach in this sample, what will happen? The molecule in the electronic level, okay, the molecule will having atom will have their own electrons. So the electronic level, what will have? Those electrons, suppose they are now in ground state. After taking this radiation, what will happen? These are the electron. What will happen? It will move to the excited state, right? So how they are moving to the excited state? They are taking this h nu energy, right? In this radiation, they are absorbing the energy and they are reaching to the excited state. So whatever is coming out from this side, this radiation I, it will be your whatever the absorbance here. Okay, from I0 minus this absorbance. Okay, then only this I. So directly we can say that this I will become your I0 minus whatever h nu it is absorbing, correct? This much. Suppose it is absorbing h nu. Okay, we are just saying that here I0 is going, here I is coming out, and whatever energy it is absorbing, that is h nu. So this h nu we are just we have to minus it, right? So now based on this, our system will automatically calculate how much radiation our molecule has absorbed. Okay, so this thing only, this Beer's law and Lambert's law has explained, and whatever formula we will get final from this Beer's law and Lambert's law, that will help you out to solve the problems, right? We have problems from PYQs, we'll solve it. Okay, so now see the Lambert's law. Lambert's law says that, right, the rate of decrease of intensity of radiation with the thickness of the absorbing path is directly proportional to the incident radiation. This Lambert's law is telling, right? So it is saying that whatever the incident radiation is there, when you are passing through the sample, what is happening? This will absorb, okay, and this will depend on this value, x value, okay. The more the value of x, the more it will absorb, and the lesser it will transmit, okay. By this definition, we are coming to know these points, correct? So that so minus di by dx, okay, is directly proportional to thickness of the absorbing path is directly proportional to the intensity incident radiation, right? So we can write I0. So how it will form, like proportional, we have to break it this proportional, right? Just convert it to it will be K, and then here it will be I0. So what is this K? This is proportionality constant, or we can say that absorption coefficient, okay, absorption coefficient, correct. And I0 is incident radiation, I is your transmitted radiation, X is the path length, correct. This is Lambert's law. Let's see Beer's law, and then final equation we will write and we'll solve some problem. Okay. Okay. Beer's law. Okay. So what Beer's law says, whatever Lambert's law it was there, just add it. It is depend on the path length, intensity, as well as the concentration of the media, the solution, the sample we have kept, okay, the sample we have kept, it is depend on its concentration also. That Lambert's law, it was not saying that it is depend on concentration, but now Beer's law, everything is same for the, like what Lambert's law is telling, only the extra thing, it is also directly proportional to the concentration of the sample. It means the more the concentration of sample, it will absorb more radiation and your transmittance radiation will be lesser, correct. So likewise they can modify your question in upcoming examination. Maybe they'll play this with this formula, they will directly put this figure and they'll ask what is the role of concentration, whether we are increasing the concentration and simultaneously we are decreasing the path length, okay. So what it will happen, so if we are increasing the path length, what will happen? If we are decreasing, if we are making half of the path length, what is happening? Like these questions they may ask you, right? So this depends on concentration of sample. So in mathematical way, how we are going to write? Di by dx, okay, because this path length is x, correct. So the proportional to incident radiation and concentration, okay, directly proportional to incident radiation and concentration. So now you just replace this proportionality, so it will become minus di by dx equal to, it will be k prime I0 and then c, where the k prime is the proportionality constant, again I0 is incident radiation and c is the concentration of the sample, how much concentration you have taken, mole per liter, correct. So this proportionality constant, we call it molar absorption coefficient, okay, molar absorption coefficient, okay, molar absorption coefficient. Previously the K was absorption coefficient, okay, there we have not added the concentration term, so it was not molar, but we know here the molar solution, right, the mole, that the mole per liter, okay. So this is the molar concentration we have. So these two equations, this equation and the previous one, Lambert's equation, if both you are combining, finally you will get it log I0 incident radiation divided by transmitted radiation equal to, what will happen? Epsilon CL, okay. This is equal to A. A is absorbance, finally we got the absorbance equation. Okay, now we will solve the problem. So this is the absorbance. This epsilon is your molar absorptivity coefficient. Molar absorptivity coefficient. They may ask this question, what is epsilon? Okay, so this is your k prime and k. Okay, that is both the like k prime and k. Then they have solved and they got this epsilon, correct? So now this C is your molar concentration or concentration of the solution. Okay, or concentration of the sample. Okay, not solution. It will become solution once sample you are dissolving. So concentration of the sample. What is L? L is the path length. Okay, L is path length. So this one. Okay, instead of X they are writing L. So L is path length. With this formula you will be calculating all your absorbance problem. Here we have one problem from PYQ, question number 53 from 2021. Okay, with this formula only we are solving. Now what I am doing, like as I discussing the concept, immediately after the concept I am taking the PYQs. Okay, it is not like that completely I will finish first concept and then I am taking PYQs. Many of the students ask me, sir, simultaneously you do it, so it will be better understanding for us. Directly we can see that from which concept which question has been taken. So like I am also doing the same thing. Now going forward, what you will get it till your examination, IIT JAM examination. Now I'll take the concept and based on that concept, how many questions they have asked, that I'll solve it first, and then I'll move to the next question with the in that same topic. We'll move to the next question concept, and then we'll take the PYQs, and then like that we will move it. Okay. So now the question number 53 from 2021. Question number 53. You can see in the screen what they are asking. The intensity of a monochromatic visible light is reduced by 90%. 90% it has reduced. Means they are saying that I0 if it is 100, then I will be 10 because 90% it has reduced, correct? So let the incident radiation be 100, correct? I'll just explain you with graphical way. This is I0 and this is I, and here the absorption is taking place. Okay. Now what is happening? This incident radiation is suppose 100, 90% it is absorbing here, and then remaining is 10%. Okay. So likewise I0 and I we got it. Remaining what is that? See, absorption on passing through a 5 millimolar solution. So concentration they have given 5 into 10 to the power minus 3 molar. Okay, concentration they have given because millimolar I have converted to molar solution of a compound. If the path length is 4 cm, just see path length they have given 4 cm, and then the molar existing coefficient of the compound. So molar existing coefficient or molar absorptivity coefficient is same. They are asking epsilon. What is the value of epsilon? So we know that final absorption formula. What we know? We know that log I0 by I equal to epsilon CL. Okay, just put the values. Log, it will be 100 divided by 10 equal to, we have to find it out this epsilon, and then here it will be, see how much it is, 5 into 10 to the power minus 3 into L, path length is 4 cm. Okay, and your answer will be in percent. Okay, per molar per centimeter. So we are not going to change this centimeter to meter. Just see the unit. Okay, if they are asking in meter, you have to convert it to the meter, right? So now it will be 10, and we know that, so log 10 equal to, it will be 5 4s are 20 into 10 to the power minus 3, and then epsilon log 10 equal to 1, we know. Okay, so epsilon equal to it will be 1. So 1 divided by this will like cross multiply, right? This will come down. So how much will come? 20, and this will be 10 to the power 3. So directly we can write 1000 divided by 20. It will get cancelled. 2 into 50. So how much we are getting? 50 per mole per centimeter. Okay, so your answer will be 50. Okay, so for this NAT type question, your answer will be 50. Correct? So based on the Beer-Lambert's law, one problem they asked in 2021. In 2023 again you will get one problem based on Beer-Lambert's law. You see that, okay? It definitely you will get it. Okay, so moving to the next question, we'll see. And then after that question, some extra concept I'll give you, okay, which will be helping you out, because I have seen that they have not asked those questions. I think initially they were asking 2016, 2017, 2018 they were asking, but now they have stopped those questions. But still, it's my personal guess that maybe they are going to ask in this year. Okay, so that's why I'll give you those things. But we'll see the next question first. It is from 2022. Okay, 2022 question number 57. Okay, question number 57 from 2022. Correct. You can see the question in the screen. Two closed line bands in a UV spectrum occurs at 274 nanometer and 269 nanometer. Okay, so we can write the lambda 1 equal to 274 nanometer and lambda 2 equal to 269 nanometer. Correct. The magnitude of the energy gap between the two bands is per centimeter. In per centimeter they are asking. So we know the wave number. Each one, if you are calculating wave number 1 and wave number 2, it will be 1 by 8. Just find it out. Wave number 1, how much it will be? Because what they are asking, they are asking this one, okay? Wave number difference. So wave number 1 will be 1 by 274. Okay? And it will be 10 to the power minus 9. 10 to the power 9 will be in up. So 10 to the power 9 per meter. Okay, per centimeter they are asking. So directly we'll write 10 to the power 7 centimeter inverse. And we have wave number 2 equal to 1 by 269 into 10 to the power 7 per centimeter. Because nanometer I have converted to centimeter. Okay, so these two value you have to just minus it. So that now in this formula, if you are putting, how much it will come? It will be 1 by simply we are not going to write this. Simply we will write 2 minus 1. Just put the value for 2. How much it is there? 1 by 269 minus 1 by 274 and 10 to the power into 10 to the power 7 per centimeter. Correct? Just you solve this, you will get the answer. If you are top, it will be 274 minus 269. Down it will be 269 into 274. How much it is coming? 4, 9, it will be 5. 5 this will be into 10 to the power 7. Okay, 5 divided by, okay, I just calculated and I kept 269 into 274. How much it is coming? Just see. It will be your 73706. 73706. And what you have to do, from this 7 you just take 1, 2, 3, 4, 0. Then it will become 10 to the power 3. Okay, 4 0 you have taken out, so it will be 10 to the power 3. Now how much it is coming? If you are dividing this one, I have just calculated, it will be 0.678 into 10 to the power 3. So final answer will be 678, okay, per centimeter. So 678 per centimeter you are getting answer here. Correct? Now these two questions they have asked, and then now I'll give you that extra things which they are going they were asking in 2016, 2017 and 2000 maybe they have asked in 2018 also, but they have stopped after that. 19, 20, 21, 22 I have not seen any question based on those topics, but those topics are very much important. We'll see. Okay, just two concepts is there. Those two concepts I'll just tell you. Once you see, you will be, till your examination it will be in your mind, I know, because you already know these things, you are already studying. Okay, one will be the electronic transitions. Okay, so how the electronic transitions are working, that will be see. Electronic transitions. Okay, this is the energy. Okay, we have sigma, we have pi, molecular orbital diagram, right? MO diagram, you know, right? This is non-bonding, this is pi star, this is sigma star, correct? So the transition is taking place. How the transition is taking place? If it is sigma bond, and if you are breaking the sigma bond, if you are exciting the sigma bond, so how they will play the questions, I'll tell you. This one is sigma to sigma star transition, okay, and this will be pi to pi star transition, correct? This will be non-bonding to sigma star transition, and this will be non-bonding to pi star transition, correct? These are the transitions. So what is the use of this electronic transition? Suppose we have carbon hydrogen bond, and we are telling that we are giving energy to this, and we want to break this bond, okay? Suppose we are breaking this bond by giving energy. So how much energy it will require? Because this is a sigma and it is breaking, so sigma to sigma star we have to give, right? So see the energy gap, it is far away, like it is more than any other transitions, correct? It means to break this sigma bond you have to give this much energy, correct? If suppose you have this carbonyl bond, and if you want to break this bond, only this particular pi bond, okay, if you are breaking this pi bond, what will happen? So pi to pi star you are moving, right? So this energy is, see, this much energy only you have, okay? And if you are comparing with this sigma bond and this pi bond energy level, you see this pi bond energy level is lesser, only this much we have, and sigma bond energy level is too much high, okay? So with this, only with this picture there are so many questions you can solve it, okay? There will be so many questions you might be solving. Now if any new bonds is forming, suppose this one, and this lone pair is approaching, not this example, I'll take another example where if suppose you have NH3 and now this lone pair is taking up this proton, okay, so we can say that NH3 and one more bond is forming, but it is plus, so it is from non-bonding to sigma star it is going, right? From non-bonding to sigma star, this one, this energy, this much energy is required to non-bonding to sigma star. If you are non-bonding, if you are breaking and making this type of bond sigma star, so this much energy is this much energy is required, correct? So energy and wavelength relation already you know, right? So if based on wavelength they are asking, then it will be the lesser wavelength, this will be the more wavelength, right? But energy wise this will be having more energy. So see, the least amount of energy is n to pi star, right? Least amount of energy is n to pi star, correct? So this is the electronic transition which I wanted to discuss with you, because maybe they are going to ask in this year questions. One more thing is there, okay, that will also I discuss. One more thing is there. That is the shift, okay? Suppose this is the graph, okay? This we can say that absorption, we call it absorption intensity graph, okay? Absorption intensity graph. Here it will be wavelength, here it will be lambda max, okay? Suppose normally this one is there, okay? Now if we are adding something, some functional group we are adding, we know that oxochrome, right? So oxochrome, if you are adding oxochrome, what will happen? Suppose if this one is shifting this side, so what we call bathochromic shift, or we call it rate shift. Why rate shift? Because your wavelength is getting increased, and we know that in the color visible spectra, the least one is for blue wavelength wise, and the more one is for red, the wavelength, okay? So wavelength is increasing in this way, correct? So red color will have more wavelength, so that's why we are telling that bathochromic shifts is another name, or another name is red shift, correct? Likewise, This one will be hypsochromic shift. Hypsochromic shift. We call it blue shift. Okay, blue shift means your wavelength is getting decreased, right? Now, but the lambda max is constant. For bathochromic shift and blue shift or hypsochromic shift or red shift, whatever you are telling, your lambda max is not changing. Okay, be careful in your question paper if they are asking that what about lambda max. If you are changing the lambda max, if your lambda max is increasing or decreasing, which shift will be your like the resultant shift will be. Okay, so the resultant shift won't be bathochromic or hypsochromic. When this bathochromic or hypsochromic shift will be taking place? When your lambda is getting increased or decreased. Okay, your wavelength is getting decreased or increased, then only your bathochromic and hypsochromic shift will be taking place. But lambda max is fully depend on intensity, right? If it is getting in like your lambda max is getting increased, we can say it's hyperchromic shift. If your lambda max is getting decreased, we call it hypochromic shift. Okay, now for this type of shift, whether it's a hypochromic shift or like hypochromic shift or hyperchromic shift, your lambda value is not changing. In the same lambda, just your lambda max means your intensity is getting decreased and increased, decrease and increase. So hypochromic and hyperchromic, but your lambda is constant. Okay, always remember this, your lambda will be constant. And suppose bathochromic shift and hypsochromic shift is taking place, your lambda will move, but your lambda max will be constant. Okay, it won't be changed. So be remember this one in your examination. Okay, so better you remember this picture. Okay, if you want, take a screenshot. Okay, it will help you out with for the so many questions from last 2 years. No, last 4 years, not 2 years. From last 4 years, they have not asked any question from that electronic transition and from this particular shift. Okay, so maybe they are going to ask. Let's see. Okay, and one more thing is that just base values I'll give you and then I'll conclude the class. Base value for UV radiation we are calculating, for UV absorption we are calculating base value because suppose you have your instrument, you can directly calculate it. For verification purpose with structure also we can calculate it. Suppose we have this type of molecule 1,3-butadiene. This is 1,3-butadiene. So what will be the base value for this? Base value is 217 nanometer. Okay, it will be like if methyl group is added 5 nanometer you are going to add it. Whether it is added here 5 nanometer you are going to add it. Okay, methyl group, chloro group, all the group is having different values, and those value you no need to remember. Only if they are going to ask, they will ask the base value of butadiene. Then they might ask base value of homonuclear conjugated diene. Okay, this will be homonuclear conjugated diene. Okay, so this is homonuclear conjugated diene. Homonuclear conjugated diene. What will be the value? 253 nanometer. Okay, correct. And for heteronuclear conjugated diene, what will be the value? This one and this one. So heteronuclear, this will be heteronuclear conjugated diene 257 nanometer. Okay, homonuclear means just be like if they are asking the name by name, directly you can write this one. If they are asking with structure, just find that those two double bonds should be in a single, like in the same ring. Okay, those double bonds should be in a same ring, then we call it homonuclear conjugated diene and the value will be 253. Okay, if suppose those double bonds are in a different ring, okay, in different ring, but it should be conjugated, correct? If it is not conjugated form, this value won't be there, right? So if it is conjugated and a double bond will be in the separate ring, we call it heteronuclear conjugated diene and the value will be 257 nanometer, correct? This arrangement, maybe we can write it here. This way also they might give you this place one and here one. Okay, likewise also they might give you, correct? So and here also one more possibilities is this one. They may give you like this and this. Okay, so whatever is there, just see and then you try to solve it. Okay, so this many only for today's class. Tomorrow I'll take it your rotational, okay, then vibrational, then NMR. Okay, small topic I'll take, but I'll cover up everything so you won't get confused in your examination. Correct? I have completed many portions of IIT JAM, and I have created a playlist for IIT JAM examination. Okay, IIT JAM PYQ. In that playlist you go, you'll find all the lectures. Okay, you'll find all the lectures. Go through with those lectures. If you are finding any difficulties, let me know. Okay, it is a complete revision series. At least you will get 35 to 40 marks easily if you are going through with those lectures. Okay, in this upcoming examination, 35 to 40 marks easily you are getting, correct? So put your like whatever the effort you are making for this upcoming examination, you have did a lot of hard work, right? So make sure you are solving, okay, those questions in your examination. Be confident, go for examination and solve all those questions. Okay, and now the time is there, so every day one lecture will come and I'll give it to I'll add it to the same playlist. So in one place you will find all the lectures, and and every day evening 7:45 p.m. I am taking live class. Okay, so you enjoy those live class. Whatever doubt you are having, you may ask. In that time I'll reply you. Okay, so thank you very much for watching.